I don't even know what it would mean to learn backpropagation before gradient descent. I think it's really fair to describe some of what's coming out of just this like next token addition as reasoning, as a kind of chain of thought. Seems pretty silly to be shaking in your boots as a software engineer.
Yeah, I've been a huge fan of your videos since I was taking like high school calculus and linear algebra in high school. So it's glad to finally meet. I was kind of finding your channel when I think you were posting the essence of calculus and essence of linear algebra
Okay,
videos for the
yeah,
first time. So those are
back to the
I
early
was
days.
already like, yeah, I was already pretty inclined towards math. So I can't say that like those videos got me into math, but it's kind of more like I discovered those videos because I was already interested in math, but then they kind of just solidified my interest even more. So that was
And you
that
clearly
was
have a
great.
knack for explaining technical things yourself. And like, is that a place your mind has always gone to, or a hobby you've always engaged with?
I appreciate that. Yeah, I think I always loved like just helping like other classmates in high school and undergrad. And yeah, I always liked like tutoring as well as like teaching to groups in general. I've just always kind of been really interested in just teaching and explaining concepts.
Hmm.
So in my view, for beginners getting started with ML, gradient descent is like the first and most important algorithm to learn. And the nitty-gritty details of backpropagation and chain rule can be explored later. So my take is that they should learn about gradient descent, linear regression, nonlinearities, multi-layer perceptrons, and then maybe they can implement a simple MLP from scratch. But curious as to what you think.
I don't even know what it would mean to learn backpropagation before gradient descent. Because like the thing that it's doing is computing a gradient. And so like the thing that
Yeah.
like why would you want to compute a gradient if you don't know that idea of descent? You mentioned linear regression. I actually think that's a great place to start. So I haven't made videos on linear regression, but if I was sitting down and rather than saying what I want to do is explain what a neural network is, I said what I want is like foundations of machine learning. I like the idea of linear regression feeling less mysterious and feeling decidedly unsexy almost, where it grounds it all such that rather than being this like black box, you're like, oh, I'm like fitting a line to data. You know, it's like, how would I fit
Yeah.
a line to data? And in that case, you know, you don't necessarily have to do a gradient descent operation. There's some nice linear algebra you can bring in to basically say like multiply
Right.
it by the right matrices and you've got it. And it might make you appreciate why one, why gradient descent is needed. With like at one point you engage with something where you can kind of find the exact solution. You want to minimize
Right.
the sum of the squares. Sometimes it's a simple enough situation you can just find the minimum. Like you project, it's great.
Yeah.
But then
Closed
realizing
form.
all the interesting stuff comes from functions that are complicated enough you can't just do the calculus or linear algebra. That's one.
Yeah.
But then also maybe trying to engage with, I don't know good examples here, but engage with gradient descent for things that aren't neural networks or situations where it's quite complicated and you realize actually just computing that gradient, it's not a given that you'll be able to do it efficiently. And knowing that the fact that backpropagation is possible sort of explains why neural networks are a good structure. Like rather than saying, hey, here's how I might imagine inference looks with all these like forward passes and layers and whatnot, and then saying, now how do I compute the gradient? Maybe a more honest depiction is to say, hey, with really complicated functions that have this huge number of parameters, it's not a given that gradients are going to be computationally feasible. But this gives a structure where you can basically factor it really nicely. So most of the things are linear, right? Like most of the things are really friendly and linear. So you can, it's not going to add complexity when you want to take
Yeah.
a derivative. But the way that you sprinkle in those nonlinearities, it's like, it's just enough to give you interesting behavior, but it's not so much that it messes up computing derivatives. Whatever
Yeah.
trajectories let you like appreciate that. Like I think the way that I did it might not necessarily be the best. I was just trying to say what are neural networks, but if I wanted to really instill those intuitions around machine learning more broadly, giving some of those other examples that help highlight what makes neural networks different rather than just making it feel like this is how it was always going to be. Of course, you were going to be able to compute the
Right.
gradient. Or like, of
Yeah.
course, it's going to look like these backward passes through multiple layers or things like that.
Yeah, yeah, I think that, yeah, I totally agree with kind of basically most of what you said. I think that kind of starting with linear regression and then motivating neural networks based on linear regression, in my experience, has been really powerful for like a lot of people getting into machine learning because obviously in terms of their representational power, MLPs can learn things way more complicated than a simple linear regression model can. But
Yeah.
apart from the nonlinearities, feed-forward networks aren't that much more than nodes that are independently performing linear regression. So,
Yeah.
yeah,
Yeah.
from
And it
that
gives you a very
sense,
like
I feel
concrete
like,
thing for something that's otherwise this big black box. It's kind of like, oh, it's not magic, right? It gives you that feeling that it's not magic.
yeah, it's like kind of like when people say, "Oh, AI is just matrix multiplication. I mean, it's a bit of an oversimplification, but at the same time, it's kind of true.
And what do you mean just? That's a very expressive, like super general thing to do.
Yeah.
But yeah, maybe what that highlights is like, what else did you think it could be other than like multiplying numbers and adding them together? Um,
Another interesting way to motivate gradient descent is the fact that, okay, sometimes this nice closed form solution isn't always going to be possible. And then you can actually obviously find the optimal parameters for like a simple linear regression model, even with gradient descent, which kind of shows that gradient descent is, even for convex and non-convex loss functions, it's like pretty universally applicable.
yeah, yeah. It also, I don't know, it sort of motivates maybe why like the beginning of almost all machine learning algorithms is to turn your data into numbers, continuous numbers, like real numbers in some way, such that it's just in the blood of anyone doing ML. They're like, of course, you're thinking in terms of vectors and tensors and all of that. But in computer science more broadly, like you have all sorts of data types. It's like, what are you going to represent? You can represent strings with your bits just fine. You can represent integers just fine. But if you wanted to say, why is it that everything's being turned into floats and why most of the operations look like addition and multiplication, if you know, oh, we're doing calculus with it, right? Like what you need to take these small steps. You're not going to be doing something where you find like this exact solution. Then you realize it would be really awkward to represent it as a string, or it would be really awkward if I was dealing with ints instead. And so that maybe hammers it in a little bit, also seeing just getting your intuition around like gradients in a lot of distinct contexts. And you're like, wow, this is quite powerful for the small cost of making sure all of my data is something I can do calculus with, which you can kind of just end up doing with almost any data. Then then we have this magical tool.
This is obviously a bit controversial, but do you think today's language models can reason? So simply scaling up these next token predictors has led to like crazy emerging abilities, models performing tasks that they weren't explicitly trained on. So with that in mind, do you think next token predictors are capable of reasoning?
I think, I mean, there's a spectrum here, right? Like often people talk about it black and white as if like now it's not reasoning, maybe it will at some point. I think it's really fair to describe some of what's coming out of just this like next token addition as reasoning, as a kind of chain of thought. Maybe it's derivative, right? In the sense that it's kind of pattern matching off of reasoning that it found in a lot of other training data. But certainly it's flexible enough that I can give it a question that it didn't see on the internet. But it's nevertheless doing something that if a child were doing it, we would describe it as reasoning. And so it's weird that next token prediction works so well. Like that's just very unexpected to me. And my understanding is when people want to get things to well, okay, so stepping back, a criticism people will lay on transformers is like this can't possibly be doing deep reasoning because there's a finite number of computations that'll happen for each new token generation. Whereas when we think about stuff, sometimes we know the answer quickly, but sometimes we know we have to like really mull it over. And there's nothing that triggers the idea that it needs to mull it over. And people will, this is like a thing being researched, right? The notion of like test time compute and all of that. But it seems like maybe the way that that'll end up happening is at this layer above, where sure, each new token generation has this finite amount of computation, but that's almost like the compute cycle. And when this reasoning happens, it's through articulating a chain of thought that maybe you hide from the user and such, but you like train it to articulate out a chain of thought. And so some problems it
Yeah,
only needs to generate a handful of tokens. Some problems it generates like tens of thousands of tokens in theory, and like
yeah,
letting it train based on that chain of thought being, rewarded or punished by whatever criteria. I
yeah,
wouldn't be surprised at all if you get very interesting results from that flavor of research, as opposed to trying to go back to the layer of like, hey, instead of a transformer doing something that is more flexible about how much compute goes into each new token. And I mean, we already see it to some extent. The fact that uh, you had a bot like do quite well on the IMO, essentially it's from something that was still in this flavor. It was bespoke to math in a way that you kind of only could be to math, but it it would seem entirely within reason that you have uh, improvements in this domain, if for no other reason for how many smart people are working on it.
yeah. I think I have a couple things to say about that. One is I think it always kind of comes back to the attention mechanism because even though it's just next token prediction, these models and specifically transformers are always factoring in all of the tokens in the context, which in some cases can be like millions of tokens long. And then the model is obviously factoring in all the tokens in the context and all the pairs of tokens in terms of the attention scores. So even though it's just next token prediction, it feels like it's still like at least somewhat akin to reasoning, since the model is still always factoring in everything it can and considering all the possible relationships between all the tokens. And then
Yeah.
kind of on another note, where you were mentioning with kind of figuring out when chain of thought is relevant and when it's not relevant, I think that's what the new O1 model from OpenAI is actually doing. It's
Hmm.
kind of taking some time on the internal side, obscure it away from the user to kind of perform some additional chain of thought.
Do we know if the way that it's doing it is through token generation? It's still just it's a transformer and it's just generating variable amounts of tokens that are kind of hidden from us, or if there's something different on the actual architectural level. Like I would assume and bet that it's transformer, but it's all happening at the level of um, chain of thought. But has there been any updates or things written on that?
Yeah, so I think OpenAI released like a brief technical overview. It's obviously not like a full research paper since they're not very open anymore.
Hmm.
But I think that the underlying architecture is still a transformer, but they've baked in some additional reinforcement learning to really get the desired output and desired chain of thought in the right situations.
And that's
So there's
reinforcement
even
on
more,
the
yeah,
like on the chain of thought itself. Like
yeah,
it would,
yeah,
and
that's my
there's something.
understanding.
Yeah,
So
yeah.
it's definitely not just a vanilla transformer anymore. There
Certainly,
seems to be
certainly,
like
certainly, yeah. But the
incremental
question is like
improvements
whether
with
all the
each
new
model.
developments are going to come from the post training that happens on the token sequences that come in this way. So as opposed to just applying gradient descent based on cost function for that particular token, there's a way of letting
Right.
part of the cost function be like this entire cohort of a chain of thought that was maybe long, maybe small, which like
That's true.
RLHF implicitly does, and then whatever other sophisticated variants people are throwing at it.
Yeah. Yeah, there's definitely been a lot of alternative architectures to the transformer in the last year. Seems like a lot of researchers are like determined to find the next architecture and dethrone the transformer. There's like a new LSTM, the XLSTM model, and there's like an architecture called Mamba, which is like an RNN variant. So definitely interesting to see if those architectures end up scaling to the same degree that
We'll
transformers
see.
have.
It could be like things that are alternatives to the like von Neumann architecture. I don't know. It's like, yeah, there's better alternatives. But then like all the computers got built on von Neumann architectures. Or rather there's trade-offs. I shouldn't say better. But then like once one kind of takes hold and the massive development is there. We'll see. Well, yeah, who knows? We'll see how those go. But in 15 years from now, maybe we can look back and see whether that analogy holds.
Yeah, it'll definitely be interesting to see. I just hope that the the architectures don't like totally become closed source and that people who aren't working at OpenAI or working at Anthropic can still learn about these architectures at the actual neural network level, the layer level, since the fact that we're even contemplating whether or not the latest models from OpenAI, like O1, are even using a transformer anymore, it definitely
Yeah.
is something to say about how machine learning research as a whole has changed in the last year or two.
Yeah, yeah, certainly. It was well, yeah. I mean, the question of like open source, closed source on this is like a whole can of worms. Um,
Yeah, for sure.
yeah.
How much math do you think beginners actually need for machine learning? A lot of ML courses start off pretty early with backpropagation, which obviously requires understanding multivariable calculus. But one of my biggest beliefs about studying ML is that gradient descent is the first algorithm everyone should learn, and arguably the intuition for gradient descent can be developed with an understanding of just single variable calculus. You don't really need multivariable calculus for that. And after learning gradient descent, students can move on to regression, nonlinearities, and MLPs, and I think that people getting started can put off backpropagation calculus until after they've gained a high level understanding of MLPs and gradient descent. But I'm curious as to what you think about this. How much math do people really need to get started with ML?
I think you can use it as a co-requisite for sure. And if anything, it motivates multivariable calculus way better than a raw, pure multivariable calculus class on its own will. There's different notions of prerequisite though. That's like you need to know the definition of a gradient before you can do this. Like, no, you don't. You just learned it on the fly. Like just in the moment, someone tells you what it is, gives you a couple
Yeah,
examples, and you get it. And then the other one is a notion of like fluency with the way that we even do math and like do the manipulations and things like that. And when you want to dig into the backpropagation calculus, for example, it just helps to be fluent with calculus in the sense of having put in the reps to do a bunch of chain rule problems yourself, such that the operations sitting in front of you don't feel like they're from a completely foreign language. You don't have to do that ahead of time to get the high level goal. And so it shouldn't be seen as like, hey, make sure you take this calculus class before you even start to engage with machine learning. But what you can highlight is saying, like, this is a part that we're about to explain that if you have that fluency, you should be able to follow. And if not, it's on me, the teacher. If you don't have that fluency, don't feel bad if you can't follow it because I'm basically speaking another language now. And like, you might want to go and learn some of that
yeah,
language before engaging. And being honest about when that's happening. So it's not very common that that will come up, but there's certain kinds of manipulation that are just kind of common in the way that people will write things about machine learning. In the same way that you would want to know algebra, just because it's part of the language that you're even using to write things symbolically, to like rearrange your equations and all of that. It's not so much, hey, you're going to use every single fact from like a high school algebra 2 class. It's just this is the
right.
language that we're using to describe it. You're going to want some familiarity with that language. Um, but broadly speaking, I think it's great to just learn on the fly as needed. And I think it's great to actually use these topics from ML as motivators for linear algebra, motivators for calculus, rather than saying, hey, before you can even engage with it, make sure that you've like walked through the
Definitely.
Pearl Castle first.
Yeah. No, I think they're definitely great motivators, and just kind of studying them when there's actually like a concrete motivator, kind of for a lot of students would probably be a lot more satisfying than having to study it from the pure math lens when they're not even aware of like the ML applications yet, anything like that.
Yeah. Yeah.
Yeah, so I think we were talking earlier about can today's models reason, and you were saying how it kind of looks like reasoning to you in in a lot of cases. So, given that you seem fairly bullish on next token prediction and language models as a whole, I'm wondering if you kind of are using like co-pilots and other language models in your day-to-day work, given that you seem pretty impressed with their performance, but are you using them on a day-to-day basis?
Yeah. I mean, to be clear, I don't know if I would describe myself as bullish. So, as on a research level, super impressed, right? But then at like a consumer level, they're quite good. I mean, I don't know, I like chatting with Claude about something while I'm learning. Um, a lot of the coding I do is like with my own tool. When I'm doing that, I don't love Copilot. It just like I kind of prefer dumber autocomplete tools. But I think when you're engaging with a new
Yeah.
programming library that you're not as fluent with, they can be amazing. Although sometimes I just want like the high level, like rather than in the moment prediction, just like asking Claude or ChatGPT about the library ends up being kind of a nice way to get the mind around it rather than like the moment by moment. Um, I probably use these tools like more than the average person, but like way less than the average tech enthusiast, if that makes any sense. I'm like a slow adopter by nature, but at the same time, it's like a field I'm more engaged with than like the average person that you just like pull out in the world. So there are clearly shortcomings, right? Like everyone knows the asterisks that you should put around like an LLM as you're engaging with it, and as long as you are aware of that, then like it's an amazing tool. But like when people are like, oh, it's it can't it hallucinates or it makes stuff up. It's like, yeah, of course it does. But like once you once you get past that, like it's still useful. Like you just are aware that it's doing that in the same way that like having an intern, they're not perfect and they're not perfectly honest or perfectly skilled, but like there's it's still amazing if you have like an intern doing things. So there's basically I feel like a lot of people are either way too excited or like not excited enough. But I I'm not in the camp of thinking like the whole world is going to fundamentally change, 3 years from now because there's going to be strong AI. Like I'd probably bearish in that sense. Um, but I'm also when people are like, "Ah, this is all just hype or something," like it's not. Like it's clearly an amazing piece of technology. So I don't know what the animal that sits between a bear and a bull is, but that's who I would actually identify with.
Oh, that's interesting to hear your perspective on that. I'd probably have the same perspective as well. Like
Hmm.
on one hand, if you were to go and kind of try to convince someone from a couple years ago before GPT-3 became publicly available through ChatGPT, and you tried to convince people that, you can generate an entire like PhD level essay in with a single prompt, or you can
Yeah.
generate the code for an entire web application within like 30 seconds. Nope, nope, nobody would probably believe you. This is like a crazy feat that was like this is worlds different from like AI code generation, whatever AI code generation we had like a couple of years ago. But on the other hand, I don't think like software engineers or data scientists are suddenly going to like lose their jobs and LLMs are going to be doing all the coding in the next year or two, like some people believe.
Yeah, yeah. The software engineers, it feels like the need for good software engineers remains strong and growing intensely. And they're the people who stand to benefit the most from it. Like the people who become way more productive. It's not someone who would have hired a software engineer, but they're using like Devin and well, I don't know the status of that one, but like it's not someone who's using the tools instead of hiring a software engineer. It's a software engineer who's like using the tools to do 3 times more than what they would have done. So it's like it is a better time than any to be a software engineer because you're the one who's actually seeing the benefits in a way that
Exactly.
other people like if you try to use these bots to build your own website, like maybe you'll get a quick web app after your first prompt. As soon as something goes wrong, then you're like, I don't know what's going. Like it something's gonna break. It's not gonna help you fix it. At least at the moment,
Yeah.
it's like very awkward. In order to even engage with it in the right ways to know how to help it, how to help it help you, you sort of have to
Yeah.
be a little bit conversant in the software. And so yeah, the notion of it replacing it might like these things might get good, and a lot of people are working really hard on software engineering bots in particular. So
Yeah.
it would be cool if that worked. I I don't know, jury's out for me, but like for the time being, it seems pretty silly to be shaking in your boots as a software engineer.